session, sir. After perhaps the bell, we can just start the repamrit session. And after that, I'll start the technical session.
Yeah.
Maybe we can start the session.
Good evening, friends. Today's webinar is being scheduled as scheduled. And we start with a remembrance session of one of our departed colleagues, professional colleagues, Mr. Bijit Sarkar, who actually, I knew him from my school days. So we were from the same school. And then thereafter, we joined in the same college. And I worked with him thereafter also. A brilliant mind is all that I can remember of Bijit Sarkar, and I can talk about a brilliant mind with ability to think laterally and ability to identify problems before they are solved. So that is what Bijit Sarkar was. He passed away a little too soon, unfortunately, but he will always he will always remain in our memory. We miss you, Bijit. Thank you.
Professor Shah had some more memories of Mr. Sarkar.
Yeah.
Good evening, everyone. It's a very sad occasion for me, but let me tell you briefly. Bijit graduated in the year 1981, 1 year after me. He was an Azadian, whereas I was a Lajpatian. I have known Bijit for a long time, since his college days, or IIT days, I would say. Jyotish Manda, of course, as rightly said, knew him from his school days. We were rivals at school because I was from Narendrapur and he was Ramakrishna Mission, and he was from South Point, and we had a rivalry going on in those days. But I came to know him very closely after he came back to shipbuilding, working in various organizations before that, right from his Manaksha days to the Pipavav days, and finally as a consultant naval architect. I knew him both professionally and personally. We were family friends. He was extremely sharp and talented naval architect and engineer. I personally got to know a lot of things about shipbuilding just by discussing with him. The evenings I used to come down to Calcutta, or he used to come down to Kharagpur. He was extremely quick-witted, and the best part was that he met all adversities and challenges with a big smile. I was scared, but he was never a person to be scared of any challenge. He helped us design our initial layout for the new towing tank. A lot of people will not know that we are having a new towing tank being built in the department uh, with funds from Ministry of Shipping and Port Shipping and Waterways. The initial layout was done by Bijit. He is the one who suggested that we should go for a double bottom structure because we had to vary the water depth in the tank. And because of him, I got the confidence that yes, we should go ahead with that. Not only that, his extremely innovative mind helped us implement what we now know as a project with Inland Waterways of Authority of India for a mechanized system for a quick movement of river vessels, especially in the upper reaches of Ganges in Bihar and Uttar Pradesh in particular. He thought of this idea, which we had implemented, but the idea, as Mr. Jyotish Manda rightly said, was completely his. This particular system is now getting implemented by IWAI. Unfortunately, I'm very sad to say that this excellent idea of his, a very innovative idea, which will be put in place to start with at Patna and Buxar, he will not be able to see the implementation of his absolutely novel concept, which IWAI, being a government organization, accepted the idea. I will miss him both as a friend and also as a person from whom I used to get good advice, and all my problems that I faced both professionally and personally, the first person I used to discuss was Mr. Vijit Sarkar. He was of extremely cheerful disposition, and you can see from the image that has been projected, with a friendly smile. He lived his life, and I met him at least just a week before he passed away. We were still discussing plans of what we will do after he gets treated from the hospital. But just to close, I would like to read out a small portion of a poem from Tennyson. The poem is titled as Crossing the Bar. I understand Tennyson wrote this poem while on a vessel, on a boat, and he was waiting for the high tide to bring the boat back to the shore, and the tide was just not there. Okay. This sums up Bijit's cheerfulness and the way he faced life. The lines go like this: twilight and the evening bells, and after that the dark. And may there be no sadness of farewell when I embark. I'll miss you. I'll miss Bijit. Thanks for giving me this opportunity. Thank you very much.
You also have Dr. Parimal Bhattacharya, who was professionally associated with IMSA. You can share your memories with Mr. Sarkar.
Okay, good evening, everybody. My association with Vijit was very interesting. I was his teacher as well as a professional colleague. And the best part of it was when Vijit came as a trainee to Goa Shipyard, or as a summer trainee to Goa Shipyard, where I was employed at that time. So he just barged into my cabin and said that he has come for training. So I just asked them, there are 3 of them. I just asked them, where are you putting up? They said they don't know. So I was a bachelor. So I said, you can stay with me. So that was the starting of my good association with Bijit. We did Bijit, as Professor Shah told, he had a very lateral mind. He could think out of the box. So in one dinner, we were discussing that we need to show the intricacies of the ship structures to the workmen, and that will also help the trainees to understand the intricacies of the ship's internal structures. So I was telling him that we could have built a removable wooden model if I had the required money to buy the woods and etc. So he came up with the cardboard idea, the wooden papers, the cardboard ideas joined by araldites, which was new to me. And within a month, we could make the entire ship structures model of an OPSSV, which he received as part contract from Mazagon Dock. So he also helped us, in developing the modernization drawing of Goa Shipyard. So that sort of, versatility I could see in him. And later on, as Professor Shah told, that he flourished on these sort of ideas and came up with a lot of innovative solutions. So my association as a teacher, he used to tell me that I'm, asking difficult questions and etc. But when we were colleagues, we were working together and sharing our ideas how to develop shipbuilding in Indian shipyards. So a bit of sweet memories I have. after he left, Goa Shipyard as a trainee, I didn't have much, interactions with him, although at various occasions I used to meet him, and I knew his children, his wife well, but professionally we're apart because I was working in a different shipyards and he was all the time a consultant in any organizations wherever he was working. A very jovial man, always always laughing on in any situation, and making the at very grim atmosphere very bright. So it is a very sad thing that when I heard that Bijit had passed away, and at such a young age, it was very sad to me. And I remembered those days when I was staying with him in my room, as a bachelor and enjoying the bachelor life to the full extent. I will remember that forever till I also die, and wish that his family overcomes the grievances and take the spirit of Mr. Bijit Sarkar in their own life. Thank you.
Mr. Kamal Palit has also joined us. He can share his memories with Mr. Sarkar.
Yes, please. I have joined.
Yes, sir.
Please allow me. Please.
Yes, sir. Please, sir. Please, sir. Please, sir.
Allow me to speak for 1 minute. Number one is we have paid our heartfelt condolence to the family of departed soul of Mr. Bijit Sarkar, 1981 naval architect, passed from IIT Kharagpur. My second point, sir, is I request our present INA President, Mr. Jyotisman Dasgupta, to express our deepest regards and congratulations at this session of INA meeting to Dr. R.P. Gokan, sir, for having received lifetime achievement from India's President Draupadi Murmu. He had taught us many difficult subjects in naval architecture curriculum, namely propulsion, propeller design, sea and ocean behavior, etc. May I request Mr. Jyotisman Dasgupta to pay respect to Mr. Dr. R.P. Gokan.
So we shall do that, sir, at the end of the session.
Thank you.
Surely.
Thank you.
Thank you, sir. Mr. Sarkar's
Okay.
son is also
yeah.
joined us. Yeah. Yes. Yes, sir. Please, sir, you were telling something, sir? Yes.
I was just wondering if we can invite
Yes, sir.
his family members, his son.
Yes, sir.
or
Yes, sir. His son is
daughter.
there, sir. His son
Yes.
is there, sir.
Yeah.
He cannot join us.
Thank you very much for joining.
This is Ved Sarkar's son.
Yes.
My sister.
Hello.
Both the daughter and son are there in the same image.
Thank you so much for remembering him. While we are, we are trying to go back to, or we have gone back to our normal lives. And the day to day has returned. But it's, I don't know what to say. Thank you. All I can say is thank you. To be able to remember him, to see him through your eyes. What Uncle Opisha, Professor Opisha said about his, innovative design and all of that, he would discuss with us. And he would say, he would make plans. I remember about the IWA thing about that Patna. He said, I'll go, once it's finished, I'll go, we'll show you. He had these, Uncle, he had that 3D model of that thing only, right? On his laptop that he
Yes.
kept on showing everybody.
Yes, we made a simulation of the whole thing. Okay, and he
Yeah.
also made a 3D printout of the same concept, which the IWA took it and kept it.
So he kept on, the moment he received it, he opened his laptop, saw it, and called all of us. Have a look at this. See, this is something great. This is something innovative. They're going to do this. So, yeah, I hope his work will live on. And we will remember, or you will remember him through his work. We are missing him like crazy day in, day out. But that's life. So thank you so much for remembering him, for involving us, and basically letting us see him through your eyes, because to us he was Baba. We hardly understood half the work he did, half his ideas. So Ma is here, but I don't think, is in a position to talk.
Ma is not able to get up, so it's just the two of us on camera. She's here listening in the background.
Okay.
As he said, thank you so much for your kind words. Thank you so much for letting us know how much he meant to you personally and professionally. I mean, he used to be, even though we didn't understand anything about it, he would call us to the room and, we are working on this, we are working on this. And not only his work, he would go on with, I remember, everybody's work that, this Jyotish Manda is working on this, Purimalda is working on this. I remember him since we were children, he would come up with everything. And even though he would go about it in detail.
Yes, we know all of you by name. Purimal uncle, we have heard a lot about the Goa adventures and how he had fun and how they would go out smoking in the middle of the night and all of that.
Yeah, we had
So-
fun as well as we worked day and night. IITians had the habit of working overnight.
That was his MO.
So we
That was
had
his
that
MO.
sessions.
So all these modern concepts of work-life balance and all, he didn't understand that. It was work and then life around work. So yeah.
If I may just say just a couple of words in the very short time that we have, it is very difficult.
I think we lost him. Did I lose my connection?
No, you didn't lose. I think he is.
Your connection is okay. Your connection is okay.
Okay.
Jyotish Manda has lost his connection.
Yes, I'm sorry.
Yeah, in fact, Dr. Iyengar, you may actually convey to INA.
Yes, yes.
You may request Inland Waterways Authority to, that facility,
Yes.
or at least some part of it to name after Bijitji,
Yes.
in commemoration of his contribution to the system.
Yes, yes. We'll certainly put it to the right persons.
It may not be the entire facility of that particular facility, his invention.
Yes.
Or at least the invention may be named after him.
Yes.
Whatever.
Yes.
That will be a rich tribute to him.
I honestly don't know how to respond to this. Thank you so much. Oh, Baba. This is his grandson. He is.
I'm sure he shared this one's photo in the INA group also. He shared it with everybody. Anybody and everybody he came across, he would share this one's photo. चलो बेटा दादी
With this, sir, I would request 1 minute prayer for Mr. Sarkar before we commence our technical session. We'll wait for 1 minute and remember him and pray for him for a minute, and then we can start the technical session.
Okay.
Thank you, sir. Now we will continue with the technical session, sir. In his memory, and we'll just continue a technical session for the day.
Thank you.
Yeah.
I'll drop off. We'll drop off.
Yeah.
But again, thank you so much. It's been a pleasure.
Thanks for joining. I met him one day in a couple of occasions at conferences, but his his joyous spirit was always there whenever the brief interaction that I had in my life. And that was visible everywhere as the people who were more closer to him were speaking about it. Thank you for joining. Thank you for joining.
Thank you so much for inviting us. Thank you so much.
Thank you.
Thank you.
We can start the technical session for the day. Today's technical session, INA session, is the topic for today's session is about simplifying marine HVAC systems. The chief guest for today is Sreenivas Ratnam, sir, and the speaker will be Commander Rohatgi. It's my privilege to introduce Sreenivas Ratnam, sir. He retired from the Indian Navy in September 2022. After a distinguished service of over 35 years in the Navy, his last appointment was as ADG Acquisition Tech, Maritime and Systems in the acquisition wing of the Department of Defense in the Ministry of Defense for nearly 5 years, during which he played a key role in acquiring capital assets worth over 1,80,000 crores. In addition, he played a pivotal role in the formulation of the Defense Acquisition Procedure 2020. He held 2 back-to-back appointments in leadership roles of repair yards of the Indian Navy as Commodore Superintendent NSRB Port Blair from 2011 to 2014 and General Manager refits of Naval Dockyard Visakhapatnam in 2014 to 16, during which he steered the refits of over 50% of the ships and submarines of the Indian Navy, a rare distinction for any naval officer. He is an alumnus of Andhra University College of Engineering, Naval Academy, Defense Services Staff College, Naval War College, College of Defense Management, and National Defense College. He is a recipient of the Vishesh Seva Medal in 2014. His areas of interest include military restructuring for effective change management, standardization in defense for variety reduction, ease of maintenance, and agile op logistics, indigenization and self-reliance, and reforms in military acquisition. He is a regular speaker at the National Defense College, New Delhi, College of Defense Management, Secunderabad, Naval War College, Goa, National Institute of Financial Management, Faridabad, and Lal Bahadur Shastri National Academy of Administration at Mussoorie, and at various seminars, workshops conducted by CIA, FICCI, SADM, and other defense associations. We are very privileged to have you as a chief guest, sir. Welcome, sir. It's also my privilege to introduce the speaker for the day, Commander Atul Kumar Rohatgi. He is a marine HVAC professional who is now engaged in educational activities. Excuse me. He is a marine HVAC professional who is now engaged in educational activities in the field of HVAC. Really sorry about it. He is a graduate in metallurgical engineering from IIT BHU and has done PG diploma in naval architecture from IIT Delhi and MBA from FMS Delhi University. Commander Rohatgi has led design teams in HVAC design of several Indian warships, including that of the Indian aircraft carrier Vikrant, P-15 Alpha destroyers, and also other vessels of international flags. Post-retirement from the Indian Navy, he has worked as head of engineering in a German HVAC firm, Nose Kaiser GmbH, and as a senior project manager in Johnson Controls, handling marine HVAC projects. Commander Rohatgi has been associated with the educational activities from ISHRAE platform since 2012. He has traveled internationally to spread the knowledge in HVAC design. He has conducted many technical sessions for the HVAC designers in Mazagon Docks, Larsen and Toubro, and for other naval architects in the Navy, in Naval Constructor Wing at IIT Delhi and in Shipwright School, Visakhapatnam. Presently, he is associated as Dean, ISHRAE Institute of Excellence. With this short introduction of the speaker, sir, I would now hand over the mic to the speaker for him to conduct the technical session. So, over to speaker, sir, Commander Rohatgi. You can just start your lectures.
Sir, I think your speakerphone is on mute right now, your microphone. Yeah.
So, good evening, everyone. Admiral Ratnam, senior members of INA, and thanks a lot to everyone for giving me this privilege to speak about HVAC on this platform. And the time was less, and the time for speaking is also less. So I'm wondering what all we can speak about, because HVAC is a large subject and it needs, when we get into any technical topic or any technical aspect, one can go very deep. So I kept it simple. I kept it simplifying marine HVAC to understand what are the expectations of HVAC from HVAC and what are the impacts of those expectations on HVAC requirements of ships. Opening a presentation, a simple presentation. Is it visible to you all? Can you confirm? Yeah.
Yes, it is visible.
Yes, please.
Visible, sir. You can go on full screen mode, sir. Yes, sir. Now it's on full screen mode. Thank you, sir.
Can I go ahead?
Yes, sir. Please, sir.
Yeah. So, first of all, let's try to understand, because these things have got impacts. So I'm talking about basics, and then we will talk about impacts. And in case if there is any need, any query, etc., we can get into more details about those things. So HVAC and refrigeration, that's required in ships. In fact, ships, they have varied kind of requirements. Everything that we can think of in a land-based, in a city, that is there inside the ship. The requirements of HVAC, first of all, it is about human comfort. It is about equipment cooling, because all our electronic equipments related to navigation, related to surveillance, related to weapons, they all need cooling, extensive amount of. In addition, because our ships and submarines, they have to stay away from shore, they need to preserve their pressure essence, so we need refrigeration. And then for ventilation, we need pressure, we need pressure maintenance. Now, pressure maintenance, etc., these things, we talk about air conditioning, but we don't clearly understand what is pressure maintenance. But air conditioning or ventilation cannot go without pressure maintenance. We have many of these difficulties. We had many of these difficulties because, and we also continue to have many difficulties in air conditioning, because we do not understand pressure maintenance, what is the kind of, and how things are designed and how the things are to be used at sea. Temperature control in machinery compartments, how it is done. It is done with the help of ventilation, and removal of poisonous and explosive gases. We have to understand for every compartment what is the nature of that poisonous gas? What is the nature of that gas which is going to be present? Whether it is heavier than air, whether it is lighter than air, depending on that, we will have to position the exhaust ducts. Depending on the nature of the gases, we will have to use the right kind of fans, because fans can also lead to sparks. And in fact, because I'm just keeping it simplified, but I will just tell you something astonishing, because till the time I came to know about it, till the time I saw some videos, etc., and some technical talks, I could never think of it. Even atta is explosive. Even atta is explosive, and atta stores need a different kind of fan. So, okay, moving ahead. Talking about what is necessary for human comfort. We at times keep on fighting. I have seen people keep having arguments. We want temperature, which is, people start with 16, 17, 18, 20, or anything. There are certain times in documents written something as effective temperature, something as dry bulb temperature. People say that in case if it is written effective temperature, that is the temperature that is to be maintained. That is the temperature when I use a simple thermometer. That is the temperature I should be able to read. We need to understand those things, because everything has got an impact on the design. So talking about what is needed for comfort, it is not just temperature. It is a mix of temperature, humidity, the amount of fresh air that is present, and the amount of air movement that is taking place inside the room. We all remember that in our childhood, most of us did not have access to air conditioners, and we used to have fans, and the fans used to give us enough amount of comfort. That can happen even today, and that can happen that air conditioning, in case if it is done at a high temperature, let's say 26 or 27 degrees centigrade, and we use a fan for movement of air, that can make things comfortable, and that can lead to tremendous amount of energy conservation. We have to start thinking in terms of energy conservation also when we are thinking about air conditioning. Things cannot move. We can't keep doing air conditioning to temperatures which are very low and then wear jackets. That is not scientific. That is not reasonable. We would like to discuss. We all think that air conditioning is very easy and temperature something has to be maintained, without realizing that a simple thing like air conditioning, how many different factors can impact its performance. HVAC equipment. I have just listed some of them. I don't claim that they are all, but they are certainly some of them. So talking about what are the issues that can impact the air conditioning performance inside a particular compartment. One of them is temperature of surrounding surfaces, all the surfaces which are around it, the kind of insulation that is there and its thickness. In case of the insulation deteriorates, then the air conditioning may not remain the same. The performance of air conditioning may not remain the same, and we will have to be conscious of it. So when temperature in a compartment goes up, it does not always mean that the air conditioning of the compartment is bad. Maybe there might be something related to the adjoining compartment where the temperature has gone higher, or it might be related to something with maybe the insulation is not correct. That needs to be checked. Condition of paint outside. Ships, when they are painted fresh outside, they will be reflecting most of it. That comes with sunlight. But once the paint becomes dull, the amount of heat that is absorbed, that will go up. Compartment occupancy, many times we design compartment with a certain certain occupancy level, and during the course of ship's long life, the number of people inside the compartment that changes, that goes up, and that affects the air conditioning. Compartments electrical or electronic load, that also tends to go up with ship's life in service. Compartments lighting level, normally lighting level, I would say that it does not normally go up, but it can impact. Lighting levels, the heat loads because of lighting has been reducing. But in case if the right kind of lighting was not initially thought of, then that can lead to alarm in air conditioning issues. And the example could be that a particular compartment might have been fitted with CFL or LED, but at a later date it was realized that the CFL or LED, they are causing some kind of electronic interference, and those compartments cannot be fitted with that kind of lamps. They have to be fitted with incandescent lamps. So in case if this kind of change takes place, then that can impact the HVAC performance. Nature of activity in the compartment, initial design, what was it designed for and what is it being used for. Load distribution in the compartment. Yes, we might have the air conditioning calculation everything might be correct. However, the load, electrical load, electronic load that has been initially the exhaust was put in a particular place. The load is not exactly there. The load is somewhere else. So all that hot air will be coming in the compartment and will be mixing with the room air, compartment air before it gets exhausted. So that will raise the temperature of the compartment. Location of air and supply exhaust positions. So these things are related. So these are some of the factors that are local, that are related to the compartment. We need to, when the air conditioning is not performing well in a compartment, we need to check up on these things in the compartment itself. There could be certain issues related to the AHU, air handling unit. In Navy, we call them air treatment unit also. So whether the right chill water flow that is taking place, that is in the right quantity or not, whether it is at the right temperature or not, quantity as well as temperature, both are important. Whether there is a sufficient temperature rise or not, that's the third aspect. So right quantity, the right inlet temperature, right outlet temperature, and on that depends the temperature range. Airflow, that is whatever was the design airflow, whatever was the design fan capacity. In case if the filters get choked, the quantity can change. When there is fouling on the cooling coil, the quantity of air can change, and that will affect the air conditioning performance. And also, in case if the fan belt and pulley, they have become defective, they have become loose, the fan RPM could change, and then that can also change the air. Chill water temperature at inlet and outlet, we talked about it. Extent of fouling on the cooling coil. Now, fouling is a very common phenomena that takes place on the cooling coil, and it needs to be cleaned at regular intervals. These days of late, I have seen, particularly in land-based air conditioning, it is a common practice now, particularly after COVID, to fit ultraviolet lamps next to the cooling coils. These fitment of ultraviolet lamps retards the growth of fouling because it kills those agents, nuclei of fouling. But I mean, the time that the AHUs that I have seen, they did not used to have ultraviolet lamps, and they are very much prone to fouling. We can tomorrow, I mean, in days to come, we can have them. Filter status, I talked about it, that when filters get choked, they change the quantity of air that is passing through them. Belt and pulley on VFD drive condition. Belt and pulley, when they start slipping, the RPM of the fan can change. VFD drive condition, the frequency that is being given, the controls, the level of controls that is there, we have belt and pulley drives in AHUs on fans and motors. But these days, changes are taking place and we can have VFD drive also. So, but very few SEPs will have VFD drives. Condition of fan and motor, status of temperature and humidity sensors, whether they are working fine or not, calibrated at the right time or not. Condition of insulation on air inlet ducts, that can change because the temperature at which the air is coming into the compartment, that can change because of deterioration of insulation. So these are some of the factors that we need to check in AHU, which could affect the performance of HVAC. And this is not done. We also need to check up what are the some of the factors which are at chiller or machinery compartment level. They are temperature of water at chiller inlet and outlet. That is, we are talking of chill water right now. Chill water flow quantity, status of insulation on chill water supply in pipes. Temperature of seawater at condenser inlet and outlet, and flow quantity of seawater in condenser cooling water. So these are some of the variables or some of the aspects that we need to check in case if the HVAC performance in the compartment is working fine. We will talk about now something about effective temperature and the other psychometric parameters. Very often it has become a fashion to talk about effective temperature. We will like to have 21.5 degrees centigrade effective temperature in the compartment. Nobody realizes that effective semi temperature is just a concept, it cannot be measured. What we can measure is dry bulb temperature, wet bulb temperature, dew point, absolute humidity, relative humidity, enthalpy, scientific volume, and these things have got scientific definitions. We can design for these psychometric parameters, but we cannot design for effective temperature. So I have a submission that we all need to become sensitive to what can be done and what cannot be done. We cannot design for effective temperature. We can design for these, and as long as we can define two of them, there are 7 parameters that I have listed. As long as we can define 2 of them, the other 5 parameters will get fixed. They are all dependent, interdependent. So if we can define 2 of them, many times I have seen in specifications also more than 2 points being specified, which is incorrect, because in case if you are meeting 2 of them, the other 5 have to be there. And when there is over specification, at times there are mistakes, that the third parameter may not be matching with the first two parameters. So we can talk about 2 of them, and that will be enough. That will be good. What should be the indoor ideal condition for design? Should it be 18 degrees? Should it be 20 degrees, 21 degrees, 23, 24, 25? What it should be? What we need to understand is what will be the impact of every degree temperature reduction. Worldwide, let me tell you that today the concept is that raise the temperature of the compartment and let people dress a bit more lightly, because reducing the temperature has got serious impact on the chiller sizing, duct sizing, HU sizing, etc. Let's read the points here. A range of temperature, humidity, and air movement provides good indoor conditions. A degree lower temperature in compartment translates to roughly 8 to 10% increase in duct cross-section, fan power, and chiller load. Now, just talking about the duct cross-section, how many times we have come across those of us who have been in SEPs and those of us who have seen encountered problems, heard sailors issues. One of the issues that we hear that in messes they do not have sufficient space in the third top bunk. Above that, there is not enough space because there is a duct passing over and the duct cross size is too big. Now, what do we do? If we want a lower temperature in the compartment, the duct size will have to be, for every 1 degree decrease, the duct size will be, the cross section will be 10% bigger. And this will be not just the duct size, this will be also the chiller size, this will also be the HU size, there will also be more energy consumption. All those things go together with it. And then is it wise to spend power to cool the indoors to a shivering condition and force the inhabitants to wear warm jackets in summer and then complain that we do not have space? So we will have to be realistic in our designs. We will have to be realistic in our expectations. I have a feeling that my personal experience is that 26 or 25 degrees centigrade with 50% RH and 0.5 meter per second air speed will keep most persons indoor in comfortable conditions. Now, this is a statistics. Around 80 to 85% of people will be comfortable with that kind of temperature. 20% or 15% may not be, they might like to have a lower temperature. But believe me that when we go for lower temperature, there will be at least 20 to 25% more who will say that the temperature is a bit too cold. So we have to be realistic, and we have to see what will keep most persons comfortable. Now I am showing you the external design condition. There have been several documents which say that we should consider the external design design condition to which level, and we all feel that it should be as stringent as possible. But these things have impacts. I will tell you that what could be the impact. The first thing that the first row that I have written, DEFSTAN is the defense standard, and pre-2005 standards used to say that 35 degrees centigrade dry bulb temperature and 30 degrees centigrade wet bulb temperature, that is what is to be, the ships are to be designed for that. That should be the outdoor condition. That has got a enthalpy. This quality of air has got enthalpy, that is total energy content of 99.46 kilojoule per kg, or around 100 kilojoule per kg. This is a very, very high value, very high value of enthalpy. We rarely find any condition which is higher than this. We will see that when we come down. Defense standard of which came out in 2005 said suddenly that we should be designing at 41 degrees centigrade dry bulb temperature, 39 degrees centigrade wet bulb temperature. The enthalpy in this condition will be 107 kilojoule per kg. Chennai, I have gone through the ISHRAE document. ISHRAE is a dependable, I mean, these documents are published after the survey, lot of survey, and it says that the design condition for Chennai is 41 degrees centigrade dry bulb, 25 degrees centigrade wet bulb, which corresponds to enthalpy of 77. People say that Persian Gulf is a very hot region, very hot region. The design condition there, as per ISHRAE, is 40 degrees centigrade dry bulb and 27 degrees centigrade wet bulb, which corresponds to 86 kilojoule per kg. And people say that because our ships have to go there, 39 degree or 40 degree there, we have to have the design condition has to be more stringent. But our stringent design condition, which was till 2005, was already up to 100 kilojoule per kg. Delhi, if I am considering the June condition, 44 degrees centigrade, 21.9 or 22 degrees centigrade wet bulb temperature, that corresponds to only 63 enthalpy. That is, the total energy content of air is only 63 kilojoule per kg as compared to 99. We want 157. Okay, I will leave that to you. July in Delhi, that is 74 enthalpy. August in Delhi is 80 enthalpy. Now, in case if I consider that I am taking a fresh air volume of 10,000 meter cube per hour and internal load condition is 26 degrees centigrade, 50% RH, the impact on chiller is this: 155 in this condition, 2005 DEFSTAN condition 350, whereas the Persian Gulf 111. This is the load on chiller. And Delhi June condition just around 35. Delhi August condition is more 91 because the enthalpy is more. So we have to be realistic. It will have a lot of impact. This is giving that by how much the chiller load will increase. Load on chiller will increase. And so in case if we have a very stiff condition, design condition, this is what we will have to provide for the chiller. And we also have to understand that these loads do not remain consistent. These keep changing. I will be talking about it. Impact of external temperature on heat load is, external temperature also has the effect on boundary load condition. Effect of external temperature on conducted heat load in compartment is duplicated. That is, this is another aspect of external temperature, which I agree that it is not just the the heat content in air. It is also the heat that is coming in because of conduction. But we have to remember that when we design a ship's air conditioning, we consider the sun heat to be coming from port as well as starboard at all times, whereas actually speaking, the heat can be coming only from one side. So we have certain extras there. Now, this is another thing that we have to be aware about. We have to consider in our design, and unless we consider them, our ships, our air conditioning equipments, our ducts will continue to be too big. A year has got 365 into 24 hours, that is 8760 hours. If we design everything for the peak load, and air conditioning is not such a drastic, is not a requirement for their life and death. If we design it for peak load, our equipments will be lying unused, partly loaded for most of the times. In 24 hours, there is day and night peak load. The temperature occurs at about 4 p.m. in the evening, and maybe around 1.5 to 2 hours in a day. In a year, there are seasons. The temperature changes during different seasons. And in ships, there are action stations when the electronic load and occupancy load is at peak. And there are also harbor conditions when both these loads are very, very small. And how long peak load remains in a year? Approximately 2 hours each day in 120 days of summer. Approximately 480 hours in a year, or about 5 to 5.5% of the time annually. Imagine what is the probability of that action station conditions will be there between 3 and 5 p.m. in summer months. So that means that almost about 95% of the time, my air conditioning equipment, which has been designed for peak load condition, is working under loaded condition. It is not working at full efficiency. It is not going to give you the desired results. And your equipment, we are carrying bigger equipments all the time, which is not needed. Rest 94% of the time, HVAC system is not working, is working in part load condition. It has got impact which is not only related to chiller capacity and AHQ capacity and bigger cross section. It is also related to performance, high moisture issues in lower sensible load conditions. Now, we may not know this. We may not realize this. We might think that if we design air conditioning for a bigger load, a smaller load will anyway be taken care of. But no, it does not happen. A smaller load, the loads are of two kinds, sensible load and latent load. When the sensible load gets reduced drastically, the latent load cannot be handled properly. There are problems related to it. Avoidable larger duct cross sections, bigger and heavier chiller plant, etc., which continues to bigger DAs requirements, bigger fuel tank requirements, heavier ship, lesser speed. Type of chill water system. This is also something that we all need to understand, that we have in SEPs, particularly in buildings, things have changed. We have become very, very much conscious about energy efficiency, sustainability, etc. Unfortunately, in SEPs, in marine HVAC design, we have not become so much conscious. Neither Navy is asking, nor vendors are supplying, because everyone is going for L1 and the quality, etc. The design is not done to the complete stage. Without the design, the contract is given to vendors, and when vendors take it, then they obviously will not. They will design it as per what comes cheapest to them. So they will be reluctant to give the best quality or most energy efficient equipments, etc., and which have not been asked for also. Okay, talking about chill water system, there are two kinds of chill water system. One is constant flow chill water system, and the other one is variable flow chill water system. Variable flow chill water systems is a recent development. Constant flow chill water system has been going on for long. There are features related to constant flow system that they are very, very rugged, and once installed, they're nothing much goes wrong. So that's okay. That's a good point there. But it has got certain things which are associated, which we need to understand. many times when we talk to the engineering officers, we find that they switch off air conditioning, some of the air conditioning equipments, and also some of the pumps in night time, thinking that the loads are less, so many pumps and so many chill water plants are not needed. But what we have to remember that when we design a particular ship, a particular chill water system with constant flow equipments, constant flow idea, constant flow concept, then the number of pumps, whether it is daytime or nighttime, whether it is action station or harbor station, that cannot change. If there are 3 pumps which are to be running, three pumps are to be running at all times. We cannot reduce the number of pumps. If we reduce the number of pumps, the chill water flow that is taking place will change, and the performance of equipment will not be correct in night time. There are other reasons also why the performance of equipment will not be correct, but this will also be a reason that the equipments will not be getting the required quantity of chill water in night time, and they will not be able. This constant flow system, they have the thing that we can recognize is that one thing is that the pumps are fixed RPM pumps, and then they have 3-way valves near the air handling units or near AHUs. Water continues to flow through all AHUs and achieves whether cooling is required or not. And this necessitates that same number of pumps must remain working whether it is day or night, whatever time it might be. The next thing that I intend to talk about is air balance drawing. Now, recently we have started making air balance drawing, but till very recent times, air balance drawing was not drawn. We never thought that it is necessary, and we still do not understand when it comes to operation that air balance is necessary, and because of that, there are moisture issues. There are different kinds of problems. So air balance drawings are prepared after completion of heat load calculation. It is whatever comes out in the calculation, all those informations, all those results are passed on to the drawing, because calculations will be difficult to see by the operators and by the maintainers, whereas drawings can be easily seen and understood by them. And this drawing helps in ensuring that the required quantity of air is not only coming to compartments, but that is also going out. Please remember that in air conditioning, in case we might have done the design correctly, heat load calculations correctly, we might have provided the ducts for fresh air, for cooling air correctly, for bringing the air correctly. But in case if air cannot go back, then air will not come in also, and cooling will not take place. For air to come in, air must go back, or there has to be a way for the air to go back. And there are many times, occasions, certain condition operating scenarios where we have not provided in previous steps the path for air to return. Now air balance is required for as simple thing as smell management. Toilet smell should not come to the passageway, or galley smell should not come to the dining hall, and dining hall smell should not come to the passageway or other living areas. So this is one very simple example where air balance can help. The other thing could be that in case if we have hospitals, etc., and we have COVID days have just passed by, infection control will just not be possible unless we consider air balance, infection control, pressure differences inside ships. It helps in odor management, moisture management, infection management, MBC management, and pressurization. Without air balancing, we cannot think about pressurization. And pressurization is not only for MBC purposes. Pressurization is not only to 2 inches of water gauge or 500 pascals, which is for Citadel. It is also of the order of 10 pascals, 15 pascals for in passageway, in galleys, etc., or room and passageway, which has to be carefully monitored, carefully designed. so that air can return. Design air balance drawing is a must. Now, one example of air balance I will talk about. I have heard of these conditions that ships have toilets through which air is being taken out continuously. And initially in the design time, people would have placed AFUs that are supplying the air to the internal compartments of the ships. So the air comes through the AFUs to the compartments, to the AHU, and then gets treated and comes to the compartment, and finally it goes out through toilets, etc., and many other exhaust openings, exhaust places. Now exhausts are working, but certain times we think that we do not need to run the AFUs. We switch off the AFUs or the supply fans. What will happen? We will have negative pressure inside. When we have negative pressure inside, whichever door is open, whichever opening is open, the air will get sucked in. And this air is untreated air. That is, it has got high moisture content, high temperature content. And this will be going air in an uncontrolled manner to any compartment. And this will cause, because it is untreated, it is carrying moisture, it will cause moisture problem, it will cause temperature problem. So air balance, it is just an example that, and it's very common that AFU supply people switch off because AFUs are not needed. This citadel is not required to be run, and the ships have been designed for that. But the exhausts are running, so the ship's entire internal area, internal space is in negative pressure, and management of temperature will not be possible. This is a depiction of air balance drawing in which in every compartment, I will not go in detail about this. In every compartment, there is a box which is written, and there are these marks which is for balancing the air. So it is done from a compartment stays to AHU stays and to citadel. For every citadel that needs to be independent, that needs to have, every citadel has to have sufficient air. There has to be a vapor air to come in. There has to be a vapor air to go out. Talking about another issue that can happen in ships where we are not able to do maintenance or temperature maintenance, where we say that HVAC performance is not good, is location of cabin supply and exhaust ports. Very many times there are 2-3 issues here. One is short circuiting of air, that is the air supply and air outlet points, they are too close, and whatever is being supplied before it gets mixed with the room air, that air is going out. So that is one problem that takes place. The other problem is that the exhaust is from the compartment, and in case if there is any electronic equipment, high load electronic equipment or electrical equipment which is there in the compartment, there is a distance between them. So what is happening is that the exhaust, that every such electronic equipment has got a cooling mechanism, a cooling blower fan, which is sucking the room air and cooling the equipment and throwing the air outside. That hot air is allowed to mix with the room air, and the room air temperature goes up. There is a temperature gradient in the room. The heat load calculations, etc., everything might be correct because of but because of the location issues, where is the exhaust and where is the equipment, the air conditioning may not be perfect. The performance may not be perfect. So we need to be careful about it. These are some very, very small, simple points, but we need to be careful about it, so to be able to control the heat load. Moisture issue is something, once again, very interesting. We can go more deep in it. We do not have time though, but at a later date, later time. We need to understand, it is a very common phenomena, very common thing to have too much of moisture, uncontrolled humidity levels in compartments. Why does this happen? Now, moisture removal takes place during dehumidification. Moisture removal takes place during dehumidification. When we are cooling the air, moisture removal also takes place. It goes together with that. Compartment temperature, and we have to do that psychometric study that what is the temperature condition at which the air will need to be supplied to the compartment. Now, what is the temperature at which the air will be supplied to the compartment? That depends on the cooling coil, number of rows in the cooling coil. Now, AHUs can be designed, same capacity AHU can be designed with cooling coils with less number of rows or with higher number of rows. When we have less number of rows, cooling coils, the cost of equipment is smaller. When we have high number of rows, the cost of the equipment is bigger. Now here, unless we know about it, unless we have specified those things, will the vendor ever supply? I have a feeling that he will not. He will like to go take the shortcut, and the moisture removal will not be taking place. In case if we have less number of rows, moisture removal will not be taking place in the equipment, and then it will be an issue for the ship. Further, if the ship's internals are in negative pressure, humidity issues are likely, which I explained to you in the previous slide. Control of humidity becomes difficult in low sensible load condition. This is what I was talking about earlier, that air conditioning will work fine in if it has been designed for peak load condition in action stations daytime condition. But the same air conditioning equipment on the ship, even if all the pumps are working, that is, it has not been decided to switch off some of the pumps. Even if all the pumps are working, in the night it is not expected to work in the same condition. Its performance will deteriorate because the moisture removal will not be taking place in the night. So the temperature, while the temperature will be maintained, the maintenance of moisture level, humidity level in night time will be difficult. We need to understand this, that this goes with the constant flow chill water system, and this problem will become bigger, get aggravated in case if our design temperatures, if our sensible loads are bigger and bigger and bigger. This problem of having more humidity problem in the night time in harbor conditions will be more when we have high sensible load. We are designing for high sensible loads. HVAC performance in terms of humidity control deteriorates in low sensible load condition. In low load condition, air has to be supplied to compartment at relatively higher temperature, that is at maybe at 17 or 18 degrees centigrade instead of regular 13 to 14 degrees centigrade. This leads to less moisture removal as compared to high sensible load condition. Problems will get aggravated when designs are done for very high external temperature condition and very low internal temperature condition. Now, a few words about the duct size. The problem that the top bunk sailor, he finds that there is hardly any place for him to change sides while sleeping, and he cannot sit on the top bunk. That is because, see, this is a simple relationship which all of us understand. Q is equal to mass into specific heat into delta T. Now, in case if you want delta T to be bigger, the Q has been calculated, the heat load has been calculated. The density of air does not change, it is fixed. CA, that is the CA of air, CP of air, it does not change. So the only thing that are variable is V and delta T. If delta T is reduced, delta T is compartment temperature and supply temperature. If compartment temperature is reduced, supply temperature cannot be reduced any further. So this delta T will be reduced. When this delta T is reduced, V will become bigger and bigger. And when V is bigger, normally delta T is 10. So if I reduce it to 9 or reduce it to 8, roughly around 10% increase will be there in V, that is volume flow rate. And this will lead to 10% bigger cross section of the duct. Another point, can electronics be cooled with water? This is last point that I am talking about. Traditionally, we have been cooling electronics with air, and electronics these days, they have very high density equipments, high heat load density equipments, which are there. And they need, in case if we want to cool them, they need dedicated AHUs for cooling them. Now, finding very large space for such large size AHUs and large size ducts, it's a nightmare. I mean, putting something in mass, something near the breast, that big an equipment, which will lead to noise also. Finding a space for ducts, it is a really difficult exercise, unnecessary difficult exercise. In case if we could avoid it and use water directly for cooling the electronics, this needs to be investigated. It is being done in places. I have examples. Data centers, which are electronic equipments, cooling is already being done with inlet water at 16 degrees centigrade. Now, why at 16 degrees centigrade? Chill water is supplied normally at between 6 and 12 degrees centigrade. But the dew point of air-conditioned air atmosphere is around 14 or 15 degrees centigrade. This water is supplied at 16 degrees centigrade above dew point with a dew point with a condensation sensor that in case if condensation is observed, the chill water flow will get reduced. This kind of cooling can really help removing those AHUs, large size ducts, all that noise, all that space requirements, etc., can be removed. And this is already being done in data centers. And even in our country, in Bangalore, Infosys, there are some data centers of Infosys, which is being used where water cooling is being done. I have quickly run through a simple presentation without getting into much detail of anything, but I can provide detail. I can have a bigger, extensive presentation on any one of these topics in case if there is a requirement, and we need to understand any of these aspects in greater detail. So thank you very much. I hope I have not taken a lot of time and I have not kept you bored. It is a challenging subject, and okay, so I'm finished from my side. Thank you very much for giving me this opportunity. It was really a privilege to talk to you all on this topic.
Thank you, sir. Now the session is open for question and answers, questions and discussions from the audience. So even as the audience are putting some questions, I have a question, sir, particularly because NAOT and some other people are designing vessels which go to the polar regions.
Mm-hmm.
Is there a significant difference in designing HVAC systems for ships which go from tropical to polar, or vessels which go only in primarily tropical waters? It just came up to me as I was listening to you.
Yes,
yes,
a very valid question and very much relevant for ships. Particularly naval ships, which have to go from the cargo vessels, etc. They could be designed for certain areas, certain passages from one place A to place B, and so they could be designed for one particular kind of condition. But naval ships, we do not know where the need will be tomorrow, and they need to go from one place to another. So all our bigger naval vessels, they are designed for such conditions, where they have the capability, where not only cooling, but also heating capacities are provided, or capabilities are provided. Now, when we do heating, let's understand that it is not just heating, it is heating and humidification. We have to understand that it is not only heating that will be required, we will also need to do humidification. We will also have to release water. Measured quantity of water vapor will have to be released inside, so that the moisture level, the RS level, can be kept within control. The RS levels are keeping a control on RS level is not only necessary for human comfort, because otherwise our skins will start cracking. It is also required for our equipments. If RS level goes down below certain levels, then it can lead to electrostatic discharges, sparking, etc. And the equipments can get burnt off. High condensation or high RS level has got a problem that condensation can take place. Similarly, low RH is also a problem. So it is not just comfort. Of course, comfort is also a requirement that we have to maintain RS, but Even equipments cannot perform in low RH conditions. We will have to have control on RH even for low, even for our equipments. So, and heaters are provided, humidifiers are provided inside AH with our air handling for this purpose. All bigger ships will have.
Mr. Palit, I think, who has a comment, he has raised his hand, sir. Please, sir.
So,
Mr. Palit, you can just.
Yeah, can you hear me, please?
Yes, sir. You're
We
loud
can
and
hear you,
clear.
sir.
I congratulate Commander Rohatgi for his wonderful presentation with various talks, tables, drawings, and explanations. But my only question to him, how does air conditioning performance gets affected by outside painting of the ships, shown in his first slide?
So,
Will you
I-
kindly
Yes, sir.
explain that?
Yes, sir. Yes, sir. I will explain that. I will explain that. So the amount of heat that will be absorbed by the on the outer surface, that depends on the reflectivity of the paint. So initially, initially when the paints are fresh, the reflection from there will be more, and very little quantity of radiated heat load that is coming from the sun will get absorbed. A lot will be reflected. Whereas when the painting is dull, a lot of that heat will be absorbed, and there will be more heat input into the compartments. So that is how it does affect. We provide at least a difference of a margin of at least 3 degrees centigrade temperature rise on the boundary for dull painting condition.
So that means we have to paint regularly to keep
Yes.
the surface shining.
Yes, sir. From air conditioning point of view, also it is a must.
Thank
It is
you.
a necessity. Yes,
Thank
sir.
you very much. Thank
Yes,
you
sir.
very much.
Sir, but just because paints were discussed,
Uh-huh.
generally in superstructures, we also do the painting primarily to reduce the signatures also. Will
Yeah.
this be a contradictory requirements? Because on one hand, we are just talking about absorption, on the other hand, we are talking about reflections.
So this could be, even if it is contradictory, certain places we have to accept it. But
Yeah.
however, when the paints are in good condition, the reflection, the heat that is coming from the sun, that will get reflected. That is what we have to observe. But in case if there is a contradictory requirement, then we have to see, what is the impact of both those conditions, both those separate requirements, and the one that we can absorb, that we will have to take it.
So one of the questions have come from one of our audiences, Mr. Mohit
Yes, sir.
Anand.
Uh-huh.
He has just asked, can you please share the effect of diffuser design on airflow into the compartment? This one of our audiences have questioned that.
Sir, yes,
Yeah.
the diffusers, they have a particular kind of flow. Now it will take a longer time. But what I can say right now is that the diffusers also have to be, the pressure at which the air comes out of the diffusers, and the speed at which the air comes out of the diffuser, and also the direction, that goes a long way in air conditioning, maintaining no temperature gradient inside the compartment. In case if I use a word called short circuiting of air. So in case if diffusers have been designed properly, they have been located properly, then short circuiting of air will not take place. Finally, the idea is that the air that is coming out of the diffuser, that must mix with the room air as much as possible, and there should be maximum distance between the inlet and outlet. That is one aspect. The other thing that we have to see is diffusers are also there to reduce the velocity of air when the air gets into the compartment, because in case if the air comes at a higher velocity, there will be more noise. Air conditioning equipments are known to be a big source of noise in different infrastructures, including ships. So we have to be very careful about the kind of the speed at which the air is finally coming out of the diffuser, and that is why we need to have large diffusers. Though the duct size is small, we need to have large diffusers, because so that finally when the air enters into the room, it comes at a low speed. And diffusers, they have internal insulation lining, which also works as acoustic lining. And finally, the direction and shapes of diffusers that hazmat effect. Now, in case if that is to be discussed, I will take more time and a separate time when we can be ready with all those presentation slides, etc. But we can discuss this, and it will be an interesting topic to be discussed.
Can we add Mr. Kalgeti to the panel? He has a comment to make or a question to ask.
So,
Sure.
Please add Mr. Kalgeti. Yes, sir, you're in the panel, sir. You can just offer your comment or questions.
Yeah.
Yes, sir.
Can you hear me now?
Yes, sir. We can hear
yes,
you.
sir.
Sir.
Yes, sir. Good evening, everybody. And before I give my comments, I would like to express deep condolences on hearing the sad demise of Mr. Bijit Sarkar. Though personally, I never met him, but I still remember having attended one of his lecture on, if my memory serves me correctly, I think he gave a talk on the piping design software which he had developed. I think the other gentleman who was with him, I do not remember. My apologies for him. But that was my only interaction with Mr. Bijit Sarkar. Otherwise, I never met him. And I would like to express my deep condolences, which may be conveyed to his family members. Now, coming back to today's talk, I must congratulate Mr. Rohatgi on his comprehensive coverage of this particular a difficult topic, actually. And perhaps due to paucity of time, some of the issues probably could not be addressed, which I'll raise in brief. But HVAC has been always a difficult issue because it is very difficult to satisfy whether crew or passengers or the entire the shipboard machinery is, some of them is depending on the correct design of HVAC. I know the naval ships are more complex because the systems and control systems are more complicated than on a merchant navy vessels. Merchant navy vessel, you have to take care of the engine control room. That too, it came in the late 70s and early 80s. But otherwise, the concept of control system was control room, engine control room was never there. Now, a few things which I would like to point out.
So,
one was probably, I think you added Sheen to your lecture if something was some mention about the choice of compressors had been, unless I missed it. In that case, I'm sorry for that. Whether you go for reciprocating or screw compressors, yes, everyone knows the screw compressor more efficient and noiseless as compared to the reciprocating compressor. I think perhaps this could have been addressed upon. Then other point was choice of material, especially for the condenser tubes. And the third one, you said the pumps, cooling water pumps should be kept running, though
yes,
it may not be necessary depending on the environmental conditions outside. But my suggestion, can you not go for VFED in that case, because it will reduce the power consumption and also keep the purpose of keeping all the pumps running. Perhaps VFED we may address this issue. Of course, you know better than me what exactly needs to be done. This is just a thought which came to my mind. And the one last point was how much additional margin is normally catered to. I mean, the TFR. How much, if it is, suppose if X is the TFR required, and how much is it, X plus 10% or X plus 20%, or there is nothing like thumb rule or anything. But I think these are the issues, some of the which I would like to point out. But otherwise, once again, my compliments to you for covering this topic very exhaustively in a given time. And before I hand over, I think I convey my New Year greetings to all the members of INA. And I have attended most of the topics, and some of the topics are really excellent and very technically very provoking. Thank you for organizing such wonderful lectures. And once again, Happy Christmas and Happy New Year 2024 to everybody. Thank you very much, Dr. Iyengar, for giving me an opportunity, sir. Thank you, sir. Yeah.
So,
Thank you. Thank you.
can I,
Thank
sir?
you. Yeah, you're mute, Dr. Iyengar.
Sir, can I speak?
Sorry, sir, Commander Rohatgi.
Yes, please.
Yeah. So, sir, I did not talk about compressor, though if required. Reciprocating compressors, by and large, they are outdated. They are not used for air conditioning any longer. We have shifted to, and particularly whenever the loads, reciprocating compressors are primarily being used today for domestic and that kind of applications. We have moved to, for bigger requirements, we have moved to screw or centrifugal compressors. As far as condenser tubes are concerned, for marine applications, what I have come across is copper nickel pipes, cupronickel pipes, 70-30 that is being used, though I did not talk about it today. Pumps, yes, I did talk about, and I said that the system, I did talk about that there are two kinds of systems. One is constant flow system and the other one is variable flow system. So constant flow systems, pumps which are traditional, which are very, very rugged, they find use in most of the ships. The constant flow system which have got constant RPM pumps, and they have three-way valves near the AHUs. Now there is an alternative available, which will be variable flow systems where VFD driven pumps will be there, motor will be there, and also there will be two-way valves, and it will be computer controlled. But I mean, there are reasons why those things are at times not trusted, that whether in difficult conditions, whether in adversarial conditions, those systems will work or not. Though in buildings, we normally today it's always VFD driven pumps will be used, and two-way valves will be used near the AHUs, so that energy conservation can take place. And sir, about additional margin, 10 to 15%. But let me tell you that air conditioning systems, they are full of margins. The systems run at 30%, 40% load, not more than that. So then there is 60, 70% margin available at all times. So you can have, I mean, you can have many more things on that. Normally on this, I mean, after a careful study, I feel that in most conditions, additional load can be given on the air conditioning system. The system is fully capable. We have to exploit it. We have to understand it and we have to exploit it. So,
thank you, sir.
Yeah.
There are some more questions from the audience. Mr. Mohit Anand.
Yes, sir.
Yes, put a question. Could you please shed some light on the relation between fan blade design, that is the angle of the blades, size and RPM, on the flow into the compartment?
Sir, I mean, I will not be able to speak much about fan flow. It will be very simple to propeller design, but though I have not been working on it, what we do is that we select fans based on its performance curves. The fans, when we when we are ready to buy, we will have the air quantity, we will have the pressure that is required to be developed, that is total pressure generated by the fan. And then what kind of fan that we will like to have, that is whether we want a blast proof fan, or whether we want a simple fan, whether we are going to use fan in hot air condition or normal air condition, cool air condition. So once we know these things, then a fan can be selected based on the fan curves that are available. And the fan manufacturers, they get into the design. Air conditioning has got many different aspects. So when we are designing air conditioning, we don't normally get into the fan design, which we leave to fan manufacturers. So,
thank you, sir. One more question from the audience. As per the DEFSTAN or NES 102,
yes, sir.
Dry bulb of 41 and wet bulb temperature of 39 degrees tropics corresponds to 88% RH, which has been the primary factor in increasing CW plant load. how to go overboard on this with the actual climatic conditions?
Sir, I had given a table, and if you permit me, I can go back to that particular table.
Yes, yes.
Yes. Yes, this is the table that I'm talking about. The Defense Standard 2005 that talks about 41 degrees centigrade dry bulb and 39-degree wet bulb. I feel that this kind of condition is too stringent. It can never be, one will never come across that kind of condition, and it is, in my opinion, not a good idea. I mean, finally, the customer is paramount. Views of the customer is paramount, but I feel that it's not a good idea to design ships for this kind of stiff conditions. We are going to unnecessarily make our ships heavy and big and bulky and unmanageable. The ducts will be unmanageable. The chiller plant will be unmanageable. The DAs will be unmanageable. The fuel tanks size will be big, and the ships will be bigger. I mean, I have a feeling that we can avoid this. The previous condition, that itself was 100 enthalpy, and when we talk about the stiff condition in Persian Gulf, it is just about 86.3 enthalpy kilojoule per kg. And in Delhi conditions are also very stiff. But even in August, when temperature is 37.7 and wet bulb temperature 26, the enthalpy is 80.5, which is much lesser as compared to this enthalpy. I have a feeling that we have to be reasonable in what we are designing for. Otherwise, I mean, finally, our things will be bulky. It will be unrealistic. It will be bulky, and it will not be energy efficient. And it will also not give us the right. I mean, I explained to you. I told you, though I have not gone into detail, why it will not be able to solve the moisture problem. It will create moisture problem for us. If we have too high sensible loads, designed for too high sensible loads, we will not be able to manage the latent loads.
Thank you, sir.
So
now, if there are no further questions or discussions, now I'll invite the chief guest to give his appreciation on the topic.
Yeah, thanks a lot, Dr. Iyengar, and my sincere thanks to INA for this opportunity. It's indeed an honor, being a marine engineer, to be in the midst of so many constructors and then get enlightened on a subject that always bothered me as a chief engineer of a ship. In the Navy, we call it engineer officer. And then heading and then running the ship repair yards. So if I generally look at the amount of time possibly as an engineer officer on board, and then in the senior leadership role in the ship repair yards, I think possibly the single largest aspect that would have taken my time is actually HVAC, AC and R. In fact, during when me and Commander Rohatgi started our careers, of course, he's about a year or two senior to me, but we both were there in Visakhapatnam. He was in the dockyard as assistant manager fabrication, and I was engineer officer of an amphibious warfare ship. So wherein he used to come to lead his team to attend the fabrication aspects of like hull repairs of my ship. And I always admired him, and for his sincerity, commitment, and then the kind of command that he had as a young lieutenant. But now I'm actually seeing him in a completely different avatar on, sharing his wisdom on a very pertinent subject. In fact, at that time, when we started our career, it used to be a very divided subject. The engineer officer used to look after only up to the chiller, and then all these trunking and everything used to be looked after by fabrication. And then these ATUs and AFUs, it was, like loosely defined responsibility between the marine engineer and then the fabricator, the constructor, and then the electrical officer. If it's going well, everybody used to claim ownership, and if it's not going well, everybody used to disown. So it is actually after this term, this actually comprehensive definition, I haven't actually heard those days HVAC and R. It used to be only AC and R, and it's only ventilation. These are the things. After these things are coined, I mean, after this term was coined, there are actually companies which were giving comprehensive like solutions. Otherwise, earlier you had only companies giving you AC and refrigeration, and there are shipbuilder who used to do the trunking part of it. So like everybody used to very conveniently blame on each other. The AC fellow used to say that no, trunking design, there is a problem. So now this kind of this actually did a lot good to the seafaring and then ship repair and then naval architects community. This whole thing being coming under one ambit. And in fact, it is like various aspects. It was extremely heartening for me to see a systematic enlightening on various aspects that have actually bothered you on a number of occasions, all through my career of about 35 years. As I mentioned to you, this is one of the subjects which possibly would have taken the largest time of mine as a ship operator and then ship maintainer. And Mr. Ullas actually brought out about the difficulties in satisfying the customer. As long as the customer or the user had a very crude way of judging. Somehow we have a sense of judging the effectiveness of AC by the extent of discomfort it causes to you out of the chill factor. And in case if you actually shiver and then cover yourself, you said AC both acha chal raha. So we have a very crude way of actually defining its efficiency. As long as we continue with that kind of ignorance, it becomes difficult. And then it also becomes our systems become actually bulkier and then bulkier, just to satisfy an ignorant customer. By the way, if you look at any piping or cabling or the system, the ventilation system is the single largest volume taker on a ship. Of course, there are actually means. What I have seen during the initial part of my career, and then what I am now seeing with advanced diffusers coming in, and then you having the higher pressure, but being diffused very well into the compartment without causing much noise. So that is actually a welcome change in actually like reducing the volume, especially in the case of a warship. The volume and then the weight is a very constrained parameters. So these things I'm seeing a lot of welcoming changes from what it was when I started my career, and then what I was seeing, towards the end of my active maritime career. And again, someone asked about because I'm a marine engineer, I thought I would. Someone asked about the compressor. Obviously, as Commander Rohatgi mentioned, it is actually screw or centrifugal compressors. It's because the noise and so many other things. And then it is also because of the capacity control becomes very easy on these things. You can actually electronically control in the case of a positive displacement compressor. Sorry, a rotary compressor than a reciprocating compressor. And then, of course, the noise and vibration, especially on board a warship, noise and vibration is an extremely critical factor. And then somebody also brought out about the blade design to the diffuser design. The blade design is primarily a factor with respect to noise and vibration, and then with respect to volume of the air handle, with respect to the amount of space that you have. and then the kind of strengthening arrangements that you can give. Because between the blade design and then the diffuser, there are actually so many things that actually control the flow as well as noise. So though it is the blade design and the diffuser design are related, but there are more important factors that actually define the choice of the blade. So the diffuser becomes a very negligible factor because you control the parameters with so many other features than actually diffuser between these two things. And then, of course, the tube materials, cupronickel 7030 C71500 is still the, for the last 20 years, this has been the material. But we've been only having advances with the finning arrangement, internal finning, external finning, and then the contours of the finning. And then again, the multi flows of air and other things that we've been having. But otherwise, cupronickel 7030 in the case of warships and 9010 in the case of commercial ships are still the prime tube materials. Of course, these days a lot of nanotechnologies are coming in just to enhance not actually the tube design, but actually the heat transfer across the tube. There's a lot of research happening, and I think the tube design and the finning design seem to have got actually like saturated the optimization of these fans. There are more and more of nano coatings and then nanotechnologies in increasing the heat transfer. So these are a few things what I thought. Like sometimes the discussion came about the switching of the chiller. Actually, the switching of the chiller in the case of a constant flow system, it is actually a jugaad kind of maybe the operator is finding some kind of a thing. Otherwise, you only do the capacity control of the compressor and then the chiller plant, because actually in a constant flow system, the flow always remains constant. In fact, somewhere like if you look at the user, I'm not talking about a HV AC specialist. Like somewhere the users and then the other stakeholders who are not so deeply into this domain, they tend to forget that the overall function of an HVAC and R system is to create an airflow and then also to filter, then cool, and then dry. We try to measure it only with the cool factor, and we tend to ignore of the other ones there. The moment you look at how complex is this system, when it needs to do all four functions, your respect for the designer of the system actually goes up multifold, so that you don't have like silly excuses to find fault either with the designer or with the manufacturer or with the operator. So with these things, I'm definitely thanks a lot to INA and my compliments to Commander Rohatgi. I leave this. I mean, when I leave this session, I am definitely much more informed, though it is a bit late in life. But I think the learning never stops. And it's a wonderful interaction. And it's my compliments to INA. That is a very professionally conducted and extremely heartening to be part of this session. And thanks a lot. And coming to the proposal that I made of honoring Mr. Sarkar about this, in case of anything, if I can, like write a letter to Ministry of Shipping, Ports and Harbor. We sometimes keep interacting with them. So I can just write a letter on my letterhead to them as a proposal. This can be a wonderful tribute to Mr. Sarkar and for his outstanding contribution. Of course, I don't have much of idea, about that innovation that he proposed. But the fact that it is being adopted and then being implemented, I think it must be a wonderful innovation. And so nice to see so many professionals from IIT Kharagpur, because my brother is a professor emeritus from IIT Kharagpur, Professor Rajkumar. Of course, he is in electronics department. I have an undeclared and the soft corner for IIT Kharagpur because my brother being. So thanks a lot for this opportunity. And Dr. Iyengar, my compliments to you and Commander Rohatgi. It's wonderful, sir, to again meet you on the screen. And I don't know this facet of yours, your like specialization in this very pertinent subject. Thanks a lot. Jai Hind.
Thank you, sir. Now I would request the President of INE, Mr. Dasgupta, to give the vote of thanks. Please.
Thank you very much, Admiral Sreenivas Ratnam, and also thank you very much, Commander Rohatgi. I think today's lecture was really a wonderful lecture, technically very pertinent, as you mentioned, and also a matter of a concern for designers, because most of the ship designers, we really struggle on this topic, especially during the preliminary design stage. I can just give a very small example. I have some colleagues, senior colleagues, Mr. Bhattacharya, who's also been a designer, that during the ship design in Mazgon Docks, where I started my working life, for a passenger vessel, we needed to have a minimum sailing height. So in the olden days, when we started, all the ducting used to be rectangular ducting. So it was during that time, in the late 70s, the circular ducts came into the bay. And we had to really struggle to minimize the amount of space above the ceiling between the decks, and the routing of the ducting was a big problem. So there has been a huge amount of change. Also, this is one of the very important topics in offshore oil and gas sector. HVAC is a very, very important aspect. So it is one of the specialization areas where this oil and gas, the HVAC is very well looked into as a separate discipline altogether. My compliments to Dr. Iyengar for identifying this and proposing this as a lecture. I'm sure everyone who attended this have benefited out of the entire session. I also thank Mr. Kalkatki, who has been the Chief Surveyor of Indian Register of Shipping, looking after the machinery, raising a few pertinent issues. Now, coming back to the request from Mr. Palit on, kind of felicitating Professor Gokarn on his achievement. I personally think, sir, it is for Professor Gokarn's felicitation, it would be inappropriate to hold a session or a discussion in his absence. For the benefit of everyone, I would rather just share the screen of his award by IIT Kharagpur as a Lifetime Achievement Award, which is a very unique award which has been conferred onto him. So if I may share the screen, I'll just share the photograph in which he receives the award from the President of India. May I share the screen, please?
Yes, sir. Yes, sir.
Yeah, okay. Thank you. So in the latest convocation, 69th convocation, Professor Gokarn, one of the the pioneers of most of the amongst the naval architects, a loved teacher and a revered teacher, He has been confirmed the Lifetime Achievement Award by IIT Kharagpur, which is indeed an honor, because I don't think any naval architect has received such an honor so far. In Institution of Naval Architects is going to hold a conference, a conclave rather, on 29th of February and 1st of March on smart green maritime in Mumbai, a physical one, in which we have plans of felicitating him in person. So we keep that in abeyance for the time being. In case anyone, especially Professor O.P. Shah,
Thank you, Jyotishmanda. But I think
wants to say a few words.
no, I think it's better we speak on the day when he's present. It is better.
Yeah,
it is better like
that is. I think that is right.
His
Yes.
presence is required.
His presence is required. You know,
Okay.
it's an honor given to him, and it would be inadequate on our part to, you know, say anything more in his absence.
That's right.
So, is that all right, Mr. Palin? Yeah, thank you, sir.
Thank you.
With
Thank
that, I thank again. I thank everyone with Admiral Ratnam, Commander Rohatgi, for the excellent deliberations, and also congratulate Dr. Iyengar. I thank INA's the background gentlemen, including Mr. Amir Ahmed, Ms. Selvi, and all the members who have been enthusing us to carry out this monthly seminar, which we sometimes find a little difficult, because this monthly seminar was done in a hurry. We have been very busy trying to conduct that conclave, so that's the reason. So done in a little bit of a hurry than what we would have preferred to. But thank you once again. Thanks a lot for attending. And with that, I would request to close this, seek your permission to close the session, sir.
Please, sir.
Yeah, thank you. Kindly close the session.